A lot of processes involving three-dimensional vectors are very similar to those of two-dimensional ones. And in this lesson, we are going to look at some of them. First off, suppose we plot a point in 2 dimensions. Let's plot the point A with coordinates, let's say 2, 3. Suppose we use O to represent the origin, then the position vector of the point A from the origin is vector OA. And in component form, a vector OA will have the components 2, 3. Now let's plot a point in 3 dimensions. Suppose the point has an x coordinate of 2, a y coordinate of 3, and say a z coordinate of 1, 2, 3, 4, 5, let's say 6. Let's call it point A, 2, 3, 6. Let's take these guides out. And let's draw the position vector of A from the origin O. So in component form, the vector OA here will have components 2, 3, 6. So the main difference here is that with a 2D vector, you will have an x component and a y component, while if you have a 3D vector, you will have an x component, a y component, and a z component. On the other hand, the unit vector form of our 2D vector here would be 2i plus 3j, while our 3D vector here would be 2i plus 3j plus 6k. Finding scalar multiples and performing addition and subtraction with 3D vectors is very similar with 2D vectors. Suppose we have these two vectors here, for example, we have the vector v with components 2, 3, -1, and w, -8, 4, 0. If we find, let's say, let's find 2v, then that would just be 2, just like with 2D vectors, 2 times 2, 3, -1. So the result will be multiply each component by the scalar, so that will be 4, 6, -2. Adding will also be similar, so actually adding and subtracting will also be similar. So if, say, for example, we have v plus w, and that will just be 2, 3, -1, plus -8, 4, 0, which gives us -6, 7, -1. Finding the magnitude is also similar. So the only difference is that we will be using 3 components. So for example, if we have the vector v with components 2, -3, +1, then the magnitude of v will just be the square root of 2 squared plus negative 3 squared plus 1 squared, which is the square root of 14. Finding the angle between two vectors is also similar. So let's say that we have vector v whose components are 1, 3, negative 2, and we have vector w with components 0, negative 4, 1. If we want to find the angle between them, it's the same formula, cosine theta. Let's say that the angle between the two vectors is theta. Then cosine theta will be equal to the dot product of v and w, so that's 1 times 0 plus 3 times negative 4 plus negative 2 times 1. It's all over the magnitude of v, which is 1 squared plus 3 squared plus negative 2 squared, times the magnitude of w, which is 0 squared plus negative 4 squared plus 1 squared. So we have cosine theta is equal to, that will be negative 14 over. And then we have here 194, that's square root of 14. This is square root of 17. So we will have here theta is equal to cos inverse of negative 14 over square root of 14 times 17. It's 238. And if you want your angle to be in, you're going to need your calculator here. If you want your angle to be in degrees, just set your calculator mode to degree, or if you want it in radian, just put your calculator mode in radian. I'm going to have mine here in degree. This is theta is it's about 155 degrees. Finding the vector equation, parametric equations, and Cartesian equations of a line in 3 dimensions would be similar process with 2 dimensions. So let's say we have this line, for example, with the points A with coordinates 4, 2, 5, and B 2, 6, 8. Let's find the vector equation first. So we will have R is equal to A plus TB, or R is equal to, for A, we can use the position vector of either A or B. I'm going to use A here. So that's going to be 4, 2, 5. And for B, as direction vector, we could either use AB or BA. I'm going to use AB, so that's going to be 2 minus 4, negative 2. Okay, that was 2 minus 4 is negative 2. 6 minus 2 is 4. And 8 minus 5 is 3. For the parametric equations, let us first, so parametric. Let us first write R as x, y, z, and then just copy the rest. 4, 2, 5 plus t, negative 2, 4, 3. And then break this down into the x part, the y, and then the c. So we will have x is equal to 4 minus 2t. Y is equal to 2 plus 4t. And z is equal to 5 plus 3t. These are the parametric equations of the line. For the Cartesian equations, or the Cartesian equation, let's express each parametric equations in terms of t and then combine them. So we will have, first one will be 2t is equal to 4 minus x. Then this is 4t is equal to y minus 2. And 3t is equal to z minus 5. And here t is equal to 4 minus x over 2. Here t is y minus 2 over 4. This is z minus 5 over 3. And because we have three expressions that are all equal to t, you could combine them all and say t is equal to 4 minus x over 2 equal to y minus 2 over 4 and equal to z minus 5 over 3. That's the Cartesian equation of the line.